let's look at the product rule under differentiation. All right. Okay, with the product rule, that is where you are given, let's say, two functions, okay, and you are multiplying the two functions. So when you are giving two functions, you are multiplying, we see how we are going to differentiate. All right. So let's say that I have y is equal to u(v), where u and v are functions involving x. Okay. So I have y is equal to u(v), and then u and v are function involving x. It means that I have one function u which may involve x, okay, and another function v which will also involve s, and the two functions are what? We are multiplying the two functions. So what will happen is that if, as I said, I have y is equal to u(v), and I want to find the differentiation dy on the x, okay, since the function for u and v, okay, all are involving x, all right, then my differentiation of dy over the x, what I will do is that I will differentiate the first function here, which is u and involving x. So I will take the first function here and I will differentiate. When I differentiate, I will maintain the other function. All right. So let's say what I will do is what? To maintain the second function and differentiate the second one. So I'll take the function v, I'll maintain and differentiate the function u, which may involve what? Which may involve x. Okay. Then plus, what I will do again is that then I'll also maintain the function u and I'll differentiate the function v, which will also what? Involves x. So if that happens, then my product rule becomes of dy on the x equal to maintain this function, differentiate this, plus, okay, so I maintain v, the function v, I'll differentiate u, where u involves x, so I'll say the u over the x, plus, then I'll maintain what? I'll maintain the u and I'll differentiate the second one, where the second function also what? Involve x. So this is the formula for what? For the product rule. All right. Okay, so I'm going to give example and then we look at how it is. So for example, if I have y is equal to 3x plus 5 and then x minus 7. All right, so I have this function here y is equal to 3x plus 5 multiplying x minus 7. We know that with this particular question here, all right, we can do our normal expansion and go by the normal differentiation and then we get our answer. All right. However, we can also use what? We can also, because there are two functions multiplying themselves, okay, or multiply itself, we can also use what? The product rule, where we differentiate this and maintain this, plus we differentiate this and maintain this. That's what we are saying. So here we can say that okay, the first one be my u. So my u is 3x plus 5, and the second one be what? Be my v. So my v is what? X minus 7. Okay, so my u is, so I'll take the first function here to be my u, 3x plus 5, and then I'll take the second function here to be my v, s minus 7. So if I want to use the product rule, then what I will say is that so I'm going to differentiate the first one. So the product will say that differentiate is maintained. So I'm going to differentiate what? If this is my u, if 3x plus 5 is my u, then I'm going to differentiate the u. Alright, so my du, okay, I'm differentiating u with respect to x over dx. So the u on the x, if I differentiate this, that will give me a 3, and this will be 0, so that will be 3. Then I can also differentiate dv. Okay, so differentiate dv to on the x, and that will give me 1. All right, so if I differentiate x, it is 1. Then this is 0. Okay, so now what will be my dy on the x? So my dy on my dx is going to be, okay, so I will take we're saying that what, if this my v, differentiate this and maintain this. That is the formula, v times du on the s, so that it means if this is my v and this is my u, then I will just what, differentiate this and maintain this. So what is the differentiation of this one? 3s, that plus 5, that is 3, and I'll maintain this, which is what, x minus 7. All right, plus in the second one I'll do the other way around. Okay, I'll differentiate what, I'll differentiate this and I'll maintain this. So what is the differentiation of this one? That is what, that is 1. Then I'll maintain this, that is what, 3s plus 5. Okay, so what I want you to know here, okay, with the product rule, that it's not anything difficult, and it's not something that, okay, definitely by force we have to write down this particular formula before. All right, what we have to understand with the concept of the product rule is that differentiate the first function here, maintain this one, plus then you come and differentiate the function, maintain this. That is all. So if I'm differentiating this particular to give me 3, multiply by, then you multiply by this, that is s minus a, plus, then I differentiate this one, I'll get 1, then you multiply by this, and that is out of this particular formula that what, that we have there. All right, so my dy on my dx, okay, will be equal 3 times x will give me 3x, 3 times minus 7 will give minus what, 21, plus 1 times 3s, 1 times 5 is 5. So I have 3s plus 3s here to be 6x, and then minus 21 plus 5 will be minus 16. So the differentiation of 3s plus 5 and then x minus 7 is 6s minus 16. All right, let's use the normal expansion to differentiate and see if you get the same answer as this one. All right, so you have y to be equal to 3s plus 5 multiplying x minus 7. Okay, so my y is equal to 3s times x will give me 3s squared, 3s times 7 will be minus 21s, 5 times x will give me plus 5x, 5 times minus 7 will be minus 35. All right, so my y will be equal to 3s squared minus 21 plus 5 will be minus 16x minus 35. So my dy on my dx will be equal to what? 2 multiply 3 to give me 6. Then 2 minus 1 is 1, so 6s minus 16x will give me 16. Alright, so you realize that we have the same answer also here. Okay, so when you use the product rule, the same answer that you get for this one.